Hi, I am Syed Z Hosain, CTO and founder at Aeris Communications. It is important to recognize that IoT is finally getting well past what I will call the evangelical phase of acceptance. People now expect that IoT will serve as a fundamental requirement for many markets and many services that are out there deployed today. Specifically in 2021, I think the medical area will see a tremendous growth and significant deployments of various kinds. Last year, I presented a paper of IoT applications in post-COVID times, and I postulate that we're at the point where the history of pandemics and epidemics we have already seen this century will proliferate. We will need new devices to solve this problem. So early detection and isolation of new viruses and diseases will be the forefront of medical technology requirements today. These new devices will use IoT and new transmissions sensors, new data gathering sensors for analysis to provide better outcomes for finding all of these viruses. For this, low-cost battery-operated IoT devices with new virus detection mechanisms using new sensors, perhaps using things like volatile organic compounds, VOC, from diseases that people have that they breathe out might be a capability that is going to be required by IoT. And for being, essentially, these are research areas that are being studied today for new IoT medical devices that will get deployed. The second issue in 2021 is I think there's going to be a lot of consolidation. We have too many IoT platforms out there today. We have too many people who think that deploying an IoT platform just means putting a little bit of a tool out there. These need to be reduced, where you have to have effective platforms that work well for the variety of IoT devices that are deployed. And these platforms that claim to solve all of these issues will simply not stand the test of time. So I suspect many of them will cease to exist in this coming year. Generally speaking, there are a number of issues associated with scaling the number of units deployed. Most importantly, absolutely the most important thing is customers need to recognize that the problems of dealing with these scaling issues have to be taken care of early. Because if you wait till the last moment to try and solve some of the problems you will encounter with scaling, it will be too late. And in particular, it may get expensive to repair any kind of issues that you might encounter later on. We work very closely with our customers to help understand those applications, the issues they might encounter, and to make them understand what it takes to get an application deployed at scale and what may be possible, to make sure that they've thought through all of the issues. For example, do they use automated manufacturing techniques? Do they have chip versions of SIMs that are on board their devices so that they can reprogram them over the air and make them manufacturable without having to worry about a human inserting a SIM into these devices later on? They have to manage the data flows from these devices. At scale, you can expect many megabytes to terabytes of data being transported, and you need to be able to store the data, transport the data with a reasonable cost, and then analyze that data for the application that you have in mind. So all of these are areas where we have provided white papers on various topics that customers need to read and understand what's involved in making these devices work well at scale. And also solutions engineers, people who work at our company who have experience with other customers' devices and what they've encountered and can help customers, particularly new ones, see what's possible, understand what's possible, and deploy units that are ready for scaling. And that's very important because it's far too easy for a customer to deploy a few thousand devices and think they have been successful and then not realize that they are unable to scale those devices to tens of thousands, hundreds of thousands, or potentially even millions of devices that are out there. If we're going to meet those expectations that customers have identified, for example, in the cellular IoT space, there are over 1 billion devices deployed today. In the next 3 to 4 years, we expect that number to grow to almost 3 or 4 billion devices. And if you include the low power wide area cellular networks, that number could be upwards of 7 billion. When you compare that to the requirements that were out there for other consumer markets, such as cell phones, where you had an individual on the other end of a phone who could take care of the issues, support issues, effectively the installation issues, provisioning issues, that's an entirely different situation than an enterprise that has to deploy a large number of units in an automated way where there is no human being on the other side to take care of the installation. There is no support for being able to remove and reinsert a SIM. You have to be able to program these over the air and make sure it works correctly at scale. And we help our customers with those kinds of issues. carefully. Many cellular radio module vendors, for example, are already providing support for multiband radios that can work anywhere in the world, including supplying these capabilities at a price point that makes sense for the market that you're trying to enter. These modules also, in many cases, have fallback. So if you have a 4G LTE radio module, it may fall back to 2G or 3G, because in some markets or some coverage areas, some remote regions, you might not have 4G available. Yes, you can still have to manage these devices. You still have to manage the purchases of the radio modules, for example, for the different regions, but this is something that has evolved very quickly over the past few years. Early 4G LTE radios could not work globally. Today's radios often will work globally. For example, some of the LTE-M or NB-IoT, which are low-power cellular technologies, will in fact allow you to deploy these in just about any part of the world, or have a single SKU that will work in many parts of the regions of the world where you have these applications deployed. Of course, you have to pick an IoT services provider, for example, like us, who provides a single pane of glass for managing these devices when they're out in the field. You need to get consistent device management, no matter which country the device is operating in. Otherwise, you're not going to be able to get a consistent support capability, consistent outcome for the data transmissions. And of course, it is very important to keep in mind that many countries may have data transport requirements where the data cannot be sent out of the country, and you have to make sure that your cloud solution vendors or whoever it is that you're using for storing the data, for analyzing the data, has the ability to understand what regulations and laws might exist in a particular country for data traversal, whether it can leave the national boundary or not. These are essential. You have to control your costs. You have to understand what it takes to get your devices to transmit the data from these multiple millions of devices across the boundaries of regional areas around the world, maybe many national boundaries that you have to be careful about, and where the data gets stored. And the processing, the servers, the farms of equipment you might need to process the data from these devices can add up in a hurry if you're not worrying about the costs of the IoT application that's being deployed. We have a number of capabilities that mitigate risks. For example, our cellular connectivity is a closed environment as best as we can separate it from consumer cellular networks. So for example, if you want to access your devices from the internet, we simply prevent that. We block it in many cases. When the device tries to connect to a server farm somewhere, it is set up with the rules through our firewalls and our various VPN links, for example, virtual private network links, for example, that it can only go to certain locations. It doesn't just wander all over the internet and get into trouble, for example. The SIMs can't be used for transmitting data just randomly over the internet to a random site. We make sure that customers are isolated from each other. We make sure that a set of devices from one customer doesn't impact the performance of another customer. All of the things necessary to make sure that you minimize security risks. Can you eliminate security completely? No, that's not going to happen. First of all, the security landscape is continuously evolving, and you need to make sure that you can accommodate that. So you start with the best practices that you can implement. You make sure the devices are working as best as you can, and then you make sure that you have the capability of going back and fixing it. So we strongly recommend that you need to implement over-the-air update capability, not just because you might want to add a new feature to the device, but basically because you want to also consider adding security fixes. If a device has been breached, it is very expensive to go out and replace it. A truck roll, as it's called, where you have to send a technician to change out a device or to fix a device or to update the programming of the device, could be horrendously expensive, particularly in the framework of a global deployment at scale. If you have a few 100,000 or 1 million devices that you need to touch and fix and repair a security breach, then OTA is incredibly important. And we worry about that. We help our customers understand the risks associated with what could happen. Plan for it early, ahead of the game, making sure that what you do in the design phase is taking into account all of these issues that can occur, particularly at scale, because it's one thing to fix a few hundred devices, it's another thing to fix a few thousand devices, but when you have to reach out and touch 500,000, 1 million, or maybe even 10 million devices, in a world where we're talking about deploying billions of IoT devices, that can get expensive in a hurry. So plan for it, make sure you do the best job you can in reducing the security risks and or allowing for fixes to take place effectively later on. That was definitely a very worthwhile session. the phenomenal growth in the number of IoT devices has been predicted by the analysts. And if we're going to achieve that phenomenal growth, the scaling requirements are going to require businesses and IoT developments to scale extremely rapidly. This will require businesses to implement automated manufacturing, high-speed provisioning, automated provisioning in many cases, and the ability to install and support the large number of devices that are going to be out there in the field. Scaling and security are the two main problems that face IoT in general. And as you can tell from the session, there was a strong interest in ensuring that the security breaches do not cause a serious problem once these units are deployed out in the field. Once we have a large number of devices that have been deployed, any breach will have tremendous consequences, and we need to avoid that. We need to avoid having IoT get a black eye. We need to make sure that when we scale, we're able to deal with these issues that would crop up.